So when we are sending the more fuel to the engine, then the speed will getting to be okay mean equilibrium, mean speed. That may also catch us to the mean speed. So that may also happen in our particular system. Okay. Now coming to the first one, centrifugal governors. Okay, is also two types are there. That is in that pendulum type and loaded type. Pendulum type example is the watt governor. Just you will observe that. Pendulum type is watt governor. Watt governor is there. So just you will observe watt governor. So that examples are also there. Watt governor examples. Okay. Here they may also arise in the three cases. Those are the it is the simplest form of centrifugal governor. It is also a watt governor. Just all of you observe that. The first case is three cases are there. That is the pivot P. Okay, pivot P. P is the pivot. So the pivot P may be on the spindle axis. That is the figure A. May be on the spindle axis. So that is the first case. When we take the our watt governor, that pivoted point, okay, set up on a spindle axis. So that is the our case A. And case B, the pivoted point, okay, the pivoted point may be offset from the spindle axis. May be offset from the spindle axis. That is also okay before the fixed point. Before the fixed point, they may get the some offset. So that is the figure B. And the third condition, the pivoted points, okay, may be offset after the fixed point. So fixed point O is there. Fixed point O is also there. So when we measure the height of the governor, that is okay difference between the our fixed point to the fly ball center. So that is taken as the our height of the governor. That is also a very important term. And another term is radius of rotation. That is represented with the small r. Okay, radius of rotation. That is the difference between the our fly ball center to the spindle axis. That is the r is there. Here we have the three cases. Those are the first one is pivoted point may be on the offset, and pivoted point first case is the pivoted point may be on the spindle axis, and the second one pivot is the may be offset before the fixed point, and the third one pivot P may be offset after the fixed point, after the fixed axis. Okay, fixed point. So now here they may also give the okay 3D diagram and 2D diagram. So that is the this is the our this diagram will represents the offset. Okay, before the fixed point. So offset. So and H value will also represent here. And second one, this is the our okay maybe on the spindle axis. The pivot P is maybe on the spindle axis. Then they may also represent here. So here we have the some okay terms, important terms. So those are the height of the governor and speed, equilibrium speed, and in this mean equilibrium speed. So mean equilibrium speed means it is the speed at the mean position of the balls. Okay, at the mean position of the balls or the sleeve. So that is taken as the our mean equilibrium speed. And now maximum and minimum equilibrium speeds and sleeve lift. So it is the vertical distance when the sleeve travels due to the change in equilibrium speed. It is the vertical distance which when the sleeve travels due to the change in the equilibrium speed. That is okay considered as the our okay sleeve lift. And these are the terms generally used in our governors. So please respond to number 76. Are you visible to my screen? Are you visible? Please respond. Roll number 302.
Yes, sir.
Are you visible my screen?
Yes, sir.
Okay. So just all of you observe the derivation part of the watt governor. It is the very simplest derivation. This chapter is also going on the only equilibrium speeds. Equilibrium conditions followed by the only equilibrium conditions. Just you will observe that. So in our diagram, okay, watt governor diagram. So they may also take the condition, okay, case one. So that is the pivot P okay, on the spindle axis. It would be on spindle axis. So then what are the forces are there in our system? So just all of you observe that. So the forces are centrifugal force. The fly balls are having the centrifugal force FC is there. That centrifugal force is acting towards outside of the our towards outside of the our governor. And another one is fly ball weight. So that weight is there. So that weight is also there. That is the second force. And another thing is there, that is the tension will acting on the arms, already known. Okay, so that is there. And HR, what is the H and what is the R? So this is the height of the governor and this is the radius of rotation R. So here we will assume that we are also taking the one assumption of our observer. So that is the weight of the arms and links and sleeve are negligible as compared to the fly ball weight. As compared to the fly ball weight. So now the ball is in equilibrium. So now they may also take that the ball is in equilibrium condition. So that means what are the forces are there? Just you will write there. So those are the centrifugal force FC is also there, and tension in the arms also there, and weight of the ball is also there. Now for getting the unknowns, just you will take the one condition from the equilibrium condition. So that is the taking the moments about pivot about the point O, taking the moments about point O. So now when we take the equilibrium, when we take the momentum at O, so then what are the forces are there? FC into H equals to W into R. They may write here FC into H equals to W into R. So W is also replacing with mg. So mgr. FC means centrifugal force, already known. So what is the formula of centrifugal force? Already we have written in earlier sessions. So that is the earlier chapters. FC means m omega square r. M omega square r into H equals to mgr. So here common same terms are cancelling here. That is the uh, cancelling here, cancelling here, and RR also cancelling here. So the remaining terms are H equals to G by omega square. Let us take the equation number 1. H equals to G by omega square. So now already known the some values. That is the G already known. Okay, so G value is known. So that is the 9.81, and omega is also known. Omega is also replacing with the term of 2 pi n by 60. 2 pi n by 60. So when we substitute both the values in our equation number 1, then we get the value. So that is the our H equals to 895 by n square. 895 by n square. So that is the our height of the governor, and uh, it may also have the relation between the our speed to the our height of the governor. H equals to 895 by n square. So here so they may also give some cases. Those are the from case 1. So simply observe that. So height of the governor is inversely proportional to the n square. And here the thing is, when the h is small, then then the speed is higher. So and second condition is, so then all of you observe that a small change in speed. Small change in speed, it is insufficient. It is a insufficient of the governor. The value of h is small. So then some insufficient is there, insufficient to enable a governor. So that means when we are having some deficiency, then we may also supply the fuel. So that may also happen in our system. And the third one is, it is generally satisfying the speeds of 60 to 80 rpm of the spindle speed. 60 to 80 rpm of the spindle. So those are the cases are there. Okay. Do you understand the derivation of our watt governor? Please respond. And are you visible my screen? Are you visible? Please respond roll number 302.
Yes, sir, it's visible, sir.
Okay. So now, are you understand that? So what is the procedure is there for getting the unknowns of height of the governor and speed of the governors? Okay, those are the unknowns. Okay, calculated by the help of small, small derivations. That means the small mathematical formulation is there. Just we are taking the equilibrium conditions. Just we are taking the equilibrium conditions. So those are the already known. What are the equilibrium conditions are there? Horizontal forces are equals to 0 and vertical forces are equals to 0, and momentum is also taken to be 0. Okay, momentum about point is also considered as the 0. So those are the conditions only utilizing in our derivations part. Okay, so now next derivation, that is belongs to the Porter governor. Porter governor. Okay. So Porter governor, it is also a modification of the Watt governor. It is also similar to the earlier one, but the thing is, we have a small amendment, that is uh, the spindle will carries the central load, the sleeve. Okay, the sleeve is also carries, okay, some central load, the spindle. Okay, so the spindle will also carries the some central load. Just we will observe the diagram. So small amendment is there between this one to earlier one. Okay, arms are there and links are there. Upper links are calling as the arms, and lower one is calling as the links. Okay, and okay, so central load is attached to the spindle. Central load is attached to the spindle or sleeve. Okay, so that is the small difference is there. Did you observe that? And another thing is there, that is the lower links are also okay. The lower links is also fixed to the D and E points. Fixed to the D and E. Not are fixed to the only at one point. So, so that is also there. Small difference is there. D and E. Okay, and our pivot is the pivot point P on the spindle axis. The pivoted point P is on the spindle axis. Okay, so that is there. And now all of you observe the diagram. Please respond. Are you visible? Are you visible my screen? Porter governor. Okay. Okay. Just observe that. Here, what are the working procedure is there? So it is also similar to the all the governors. So the thing is, okay. So when the load carries higher of our engine, so then the spindle speed will reduces. For getting the mean equilibrium speed, they may also transmit the okay. They may also send the more fuel to the our engine section. So that is there. So now going to the our derivation part. So before going to derivation part, just we will observe the diagram. It is very important. Diagram point of view and some notations. So notations are small m is there. Small m is the mass of the our fly balls, and capital small w is there. Weight of the each ball, weight of the each ball, and capital M, mass of the central load. So additionally added here. So what is the new one is there? That is the representing here. Mass of central load, and capital W, weight of central load, and small r is the radius of rotation meter. So just this is the okay diagram figure A. Those are representing here. And what are the forces are there in our particular governor. So those are represented in our figure B. So just you will observe that pivoted point P is there and fly ball that is also B represented with the the point of B and our links. Okay, and the link one end is stick to the our fly ball and another end is at D point. So now all of you observe that the arms and the links both are having the tension. Both are having the tension. The tension is arms. Okay, arms. The tension T1 in the arms and tension T2 in the links. So now height of the governor H is there from the the difference between the our pivoted point to the our fly ball center of the fly balls and angles. Those are also making the some inclinations. Okay, so our arms and our links are also making the some inclinations. Okay, those are the alpha and beta with the spindle axis. Alpha and beta angles are there with the spindle axis. Okay, those are the forces are also involved in our system. So now uh, H is again they may also shows the some notations. Those are the small h height of the governor and n is the speed of the ball and omega is the angular speed of the ball. Fc centrifugal force acting on the ball and T1 T2 uh, uh, T1 T2 tensions in the arms and the links and alpha angle of inclination of the arm and beta angle of inclination of the link. So those are the notations represented in our derivation part. Now this derivation is solved with the two methods. Those are the method of resolution of the forces and the second one is the instantaneous center method. Okay, instantaneous center method. Already we learned the instantaneous center method in our COM subject. In our COM subject, instantaneous center method and resolution of the forces. So that was also learned in our engineering mechanics. So let us go to solve the first method, that is the resolution of the forces. So now all of you observe that. Just observe the just observe the diagram. All of you observe the diagram. All of you observe the diagram. Next, all of you observe that. So when we follow the resolution of the forces method, so what are the forces are there in our system? So now considering the equilibrium of forces acting at D, considering the equilibrium of forces acting at point D. So from point D, what are the forces are there? Just you will observe the point D. What are the forces are there? What are the forces are there? So W by 2 and another force is tension is there at D. So the tension is here. Just let us take the only vertical forces, vertical components. So when we take the vertical component, those are the T2 cos beta equals to W by 2. T2 cos beta equals to W by 2. So then why? Because W by 2, central load is acting on towards downside, but T2 cos beta is going towards upside. Okay. Uh, so then T2 cos beta equals to W by 2. W is also replacing with the term. So that is the capital MG by 2. So from that T2 equals to mg by 2 cos beta. mg by 2 cos beta. Let us take the equation number 1. mg by 2 cos beta. Let us take the equation number 1. Now again considering the equilibrium of the forces acting at B now, acting at B. So what are the forces are there at B section, at the B point, at the B point. So now the point B is also in equilibrium under the action of the following forces. What are the forces? Just they may also write the first forces. So that is the weight of the fly ball is there, small W are okay, and centrifugal force FC is there, centrifugal force FC is there, and tension of okay, tension by the arms and tension by the links. T1, T2 is also. Now resolving the forces vertically. Now we will write the vertical forces. So that is the okay, that is the our T1 cos alpha, T1 cos alpha equals to T2 cos beta plus W. T1 cos alpha equals to T2 cos okay beta. Just you will observe T1 cos alpha equals to T2 cos beta plus W. So T2 cos beta means nearly to write here T2 cos beta equals to capital mg by 2. Just substitute the value. So mg by 2 plus small mg. Let us take the equation number 2. Let us take the equation number 2. Now resolving the forces horizontally. So horizontal forces. So what are the horizontal forces are there? So that is the T1 sin alpha. Okay, T1 sin alpha plus T2 sin beta equals to FC. Just you will observe the diagram. T1 sin alpha plus T2 sin beta equals to FC. Okay. So then uh, T1 sin alpha plus T2 sin beta. Sorry, T1 sin alpha plus T2 sin beta is there. So that is the our just you will observe T1 sin alpha plus T2 sin beta equals to FC. So T1 sin alpha plus T2 means mg by 2, mg by 2 cos beta, and sin beta already there. So sin beta by cos beta means tan beta. Okay, so mg by 2 into tan beta equals to FC. So then T1 sin alpha, T1 sin alpha equals to FC minus mg by 2 tan beta, FC minus mg by 2 tan beta. So let us take the equation number 3. Let us take the equation number 3. So now dividing the equation number 3 by the equation number 2. So equation number 3 and equation number 2. So that is the T1, okay, 3 equation is T1 sin alpha, okay, equals to FC minus mg by 2 into tan beta. Divide, okay, division with T1 cos alpha, okay, and our mg by 2 plus capital mg by 2 plus small mg. So when we are okay dividing, when we are division with the our 2 equation, so then we may get that is the all of you observe that. So T1 sin alpha by cos alpha, again it may also comes T1 tan alpha, T1 tan alpha. So sorry, T1 cancelling here, tan alpha is remaining the term. So then this term, okay, denominator is also send it to this side. Okay, numerator and denominator you can send it to the left side. So then mg by 2, capital mg by 2 plus small mg into tan alpha equals to fc minus capital mg by 2 into tan beta, into tan beta. So then simplifying the equation, so then capital mg by 2 plus small mg equals to fc by tan alpha minus capital mg by 2 into tan beta by tan alpha, tan beta by tan alpha. So here they may also take the one okay, one notation, new notation, that is the tan beta by tan alpha equals to q. Tan beta by tan alpha equals to q. Just all of you observe that. Tan beta by tan alpha equals to q. And tan alpha equals to r by h. Let us take the triangle of okay, just observe that this triangle, from this triangle. Just observe that this triangle P, okay, for example this triangle, right angle triangle is there. From this triangle tan alpha equals to r by h. Tan alpha equals to r by h. Why? Because r is there. Okay, opposite side r is there, and adjacent is the h is there. So tan alpha equals to r by h, and tan beta by tan alpha equals to q. It is a constant. Okay, q is there. Okay. Now those two values are substituting in our earlier equation. So when we substituted that, mg by 2 plus small mg equals to fc means m omega square r into uh, tan alpha by tan alpha means into h by r, or division with r by h. So minus capital M by capital mg by 2 into q, capital mg by 2 into q. So then when we simplify that, so m omega square h equals to small mg plus, okay, capital mg by 2 into 1 plus q. So this term mg by 2 q term is okay, send it to the this side. So that is the capital mg by 2 into 1 plus, this is the, okay, mg by 2 is there. So okay, taken out that, so that is the 1 plus q. Okay. Now h equals to, okay, h equals to mg small mg plus capital mg by 2 into 1 plus q into 1 by m omega square, 1 by m omega square. So then simplify that, that is the m small m plus capital M by 2 into 1 plus q divided with m into g by omega square, just g by omega square. So now only, now they may write the equation. Okay, it is let us take the equation number 4. Let us take the equation number 4. Now omega square equals to small mg plus capital mg by 2 into 1 plus q into 1 by mh, 1 by mh. So now it may also similarly to write here small m plus capital M by 2 into 1 plus q by small m into g by h, g by h. So here just substituted the value of omega. Omega is also written as 2 pi n by 60. Just will substitute the 2 pi n by 60 in this equation. So 2 pi n by 60 square equals to small m plus capital M by 2 into 1 plus q small m into g by h. So then n square equals to only n square. You will require the n square value. So n square equals to small m plus capital M by 2 into 1 plus q by m into g by h into 60 square by 2 pi square. 60 square by 2 pi square. When we multiply the particular term, numeric term, so then we may get the value, that is the small m plus capital M by 2 into 1 plus q by small m into 895 by h. 895 by h. Okay. So this is the, here we have determined the h value, okay, relation between the h and n. H and n speed. Okay, so that is there. And the thing is, why we write, okay, why we take the q value, why we take the q value, just all of you observe. Why? Because when the lengths of the arm and the length of the links are equal, lengths of the arms and lengths of the, okay, links both are equal lengths of the arms and our arms. So then those are also following the angle will also same. So that is the alpha equals to beta, tan alpha equals to tan beta. So then q equals to tan alpha by tan beta. So then that equals to q equals to 1, q equals to 1 in our equation. When the, okay, equal lengths of the arms and links, then q value will substitute to the 1, q value will substitute to the 1. And case 2, when the loaded sleeve moves up and down this spindle, so then the frictional forces acts on, okay, then you may also considering the frictional forces. So when we consider the frictional forces, then the speeds and our h value are. So now they may also write the only n square value. N square equals to small mg plus capital Mg plus or minus f by 2 into 1 plus q by small mg into 895 by h. Let us take the equation number 7. Let us take the equation number 7. And similarly to write here this one, small mg plus capital Mg plus or minus f by mg small mg into 895 by h. Okay, so sometimes you may also write the this equation. How we write the this equation? When the q value will takes to the 1. 1 means equal lengths of the arms and our links. So then simply to substitute the okay q value 1. When we substituted the 1, then this 2 and this 2 are cancelling and remaining term will be right here. Okay, small mg plus capital Mg plus or minus f by small mg into 894 by h. Here plus or minus is there, plus or minus. So that is the why we represent the plus or minus. The positive sign is used when the sleeve moves upward. Okay, so then the governor speed increases, and the negative sign is used when the sleeve moves decreases or downwards. When the sleeve moves downwards, that is the governor speed decreases. So that is the our case 2. And coming to the case 3 point of view, on comparing the equations 6th and 6th with the equation 2 of the ward governor. So when we compare with that, okay, our ward governor equation and our present 6th equation. So that is the we find that the mass of central load capital M increases, okay, the height of the governor ratio with the height of the governor ratio. So that is the small m plus capital M by small m. What is the difference is there between the this equation, okay, earlier equation, this equation and sorry, this equation and earlier equation. So that is the our 6th equation is there. Okay, so what is the equation is here? That equation small difference is there. That is the we are missing the 6th equation, that is the capital N square equals to small m plus capital M by small m plus capital M by small m into 895 by h. Okay, that is the 6th equation. So when we compare both the equations, what governor equation and this equation, the small difference, the small change is there. That is the multiplication of this term. That is the small m plus capital M by small m. Multiplication of okay particular term. That is the difference is there. Okay. Okay, guys. This is the Porter governor range of speed. Okay, sorry, that is the speed value of the our Porter governor. N square equals to small mg plus capital Mg plus or minus f by small mg into 895 by h. Okay.